more examples on solving by factoring. So if it's a parabola, you can try by factoring or graphing. Keep that in mind, okay? And here's some examples. A. Whoa. A has fractions on them, agreed? Huh. No, I don't think I would want to try A with factoring. It's doable, but it'll take a long time more than likely. And it's probably not worth our time doing that much. There's other techniques, such as maybe the quadratic equation or other formats that we could always use. One of them is graphing, as a matter of fact, so let's try that out. Let me clear this out, go back to my y equals. So turn on your calculator, go to y equals, and I'll clear this out. There we go. So plotting, let's try plotting this. We're going to graph the left side of our equation there, 1/2, so 1 divided by 2. And then your X button is right next to your alpha button. Pretty close to your second button, you'll see your X button. You want to push square, so you can either do the caret key below the clear button or the X squared, somewhere in the middle on the left side. I'll try the caret key just for reference. If you have a T84, you probably want to push forward now. That way it comes down from the exponent, otherwise you're going to keep writing on the exponents. T83s, you can just keep going. So for right now, so far, we're telling the calculator to do 1 divided by 2, and then multiply by x squared. Then we're going to add 4. And there it is. That's the left side of our equation or expression for A. I'll go ahead and hit enter or push down to go to the next line. And on that line, I'm going to say 11 divided by 3x. And there it is. We have both equations. So I'll go to zoom, and I'll do a zoom standard, option number 6, push the button number 6, or go down to number 6 and hit enter. Either would work. So there it is, first graph and second graph. We can see where it intersects once, but it might intersect twice up higher. So I'll go to zoom, middle top button, and in our zoom we want to do a zoom out, option number 3. You can go down to number 3 and hit enter, or push the number 3 button and automatically goes into that feature. Do notice it doesn't zoom out. You got to tell it where to zoom out by moving the cursor. I won't move the cursor necessarily. I'll just hit enter and say zoom out at the middle, or where it's at. There it is. I zoomed out by hitting enter. Now I can see that it does intersect twice, but it's kind of hard to see. So I'll go to zoom, middle top button once again, and we want to do zoom box, option 1, hit enter. And I'll move the cursor that way I can actually see where my cursor is at. There's my cursor. I'll hit enter, and I really want to focus on the area, so I'll push up. I want to focus in the area where I want to find the intersection using a calculator. So there we go. Getting closer to the area. Yep, that's about it. That's the area that I want to see. And there it is, our first graph and then the second graph. And we can see a little bit easier where it intersects now, both of those graphs. So I want to have a calculator for me. Keep in mind, we can also do it by graphing by hand as well. Do remember that, you walk up to graph by hand also. But I assume you probably already know how to graph by hand, so I'll leave it up to you. In this case, I'll do a quick calculator workout for you, that way you can learn to use a calculator as well. If you push second, and now the trace button. So first the second button, then the trace button. Second, trace should give you this image. And we want to know where they intersect each other. So intersect, option number 5. Go down to number 5, I'll push number 5. And now, notice that I can move my cursor left or right. And if I hit enter, I'm telling it, yes, that's the first curve. That's what it's asking me, which is the first curve. I'll hit enter. And it automatically jumps, I can see at the very top, to equation number 2. And I'll tell it, yes, that's the second curve by hitting enter. And it gives me a guess. I don't want to guess. I want an exact value, so I hit enter once again, and it goes to the closest intersection point. At this point, I can see that x equals 6 is my intersection point. And we can find the other one out. Let me move it a little. Let's realize that x equals 6 is our first intersection point. And now, likewise, I'm going to try that again. Push second, trace at the top right, second to the right. You'll see the calculator option, which is this one. We want to go for the intersect option again, option number 5. And in this case, I won't hit enter yet. I'll get closer to it before I hit enter. There we go. I'm closer to the other intersection point. Otherwise, it'll give me the same point. I'll hit enter now. It jumps automatically to the second one. I'll hit enter saying yes, that's the second curve. Gives me a guess. I don't want to guess. I'll hit enter one more time. And now it gives me the other intersection point, which is at 1.3333. Or fraction-wise, we can convert that to 4/3. Agreed? So second intersection point, 1.33 or 4/3. So there it is. That's how we can calculate it using our calculator or by graphing. We can visually see where they intersect each other and give a rough estimate if you're doing it by hand. So let's continue with B then. B seems to be the one that causes more headaches. For some reason, from what I've seen in the past. But it's actually the easiest, so keep that one in mind. Don't let it cause you headaches. It's really, really easy. It's solved by factoring. Agreed? Notice, do you have to factor or is it already factored? Should be your question. In this case, we can see that it's already factored. So all I have to do in reality is split them up. There we go. We'll take the 4x plus 3 and set it equal to 0, and take the 9x minus 1 and set it equal to 0, and that's it. Now all you have to do is solve for x. You don't have to factor or expand because it's already factored. So now solving. Let's solve for one of those, the 4x, so minus 3 on both sides. That gives us 4x equals negative 3 divided by 4. And it gives us that x equals negative 3/4. Hooray, we found one of those answers. The next one, let's solve for the x, so plus 1 to both sides. And let's also get rid of the 9 by dividing, right? Dividing by 9. There we go, 9 divided by 9 cancels out, right? So that leaves us x equals 1/9. So we found both of our answers in this case. Hooray, we're done with that one. That's it. Keep that one in mind, agreed? Quick graph, that way you can see what we just did and to see that it's actually correct. Okay, one equation is all it takes for this one. One set of parentheses, 4x plus 3. There we go. Then another set of parentheses. Remember, your parentheses are right above your number keypad. And 9x minus 1. I'm going to have to worry about the equal 0 because that's going to be our x-axis. So go to zoom and do a zoom standard, option number 6. And we can sort of see where they intersect, right? Let me try zooming in to make it a little bit easier to visualize. Zoom, and let's see, I'll do a zoom box once again. I'll move my cursor so I can see. There we go. Where I want to zoom into that area. I'll hit enter once there. Push up, make a box. First line, then the box. There we go. As I move to the right, I see the box now. I'll hit enter, and now I'll see where they intersect. There's the first intersect, there's the second intersect option. And let's see, in this case, we've already got our values. So if you hit trace, top right button, second to the right, I should say, is the trace button. Trace allows you to enter any x values. I want to enter negative 3 divided by 4, which is one of our answers, and check that it gives us 0. Yeah, it does. Negative 0.75 gives us 0. And the second one, I'm still on the trace option, so I still should be able to go 1 divided by 9 and hit enter and have it check that it's the other 0. Yes, it's where the other y value is 0 once again. So our x value, 0.1111 or 1/9. So there we go. We just checked that that is correct. In the previous case, since it wasn't equal to 0, we checked that it was the intersection point of two graphs. In this case, it's equal to 0, so we're checking the x-intercepts. So we just checked and it's correct. Let's go for the next one, C. Now C is a little tricky one. Be aware of this. I wouldn't do this one through factoring. Only if I had an hour to spare. Maybe. In some cases, not always though. But this one I would probably also do by graphing our calculator. But I'll try my best for factoring first. That way you can see what I mean. So factoring. In this case, the a value is not 1, so it's not the easy form of factoring. We write multiplied equals, the 6, and it's the first 6, the one that's next to the p square. I kind of made it green, that way you can see it. And we also write multiplied equals, the second negative 6. So, or the last one, I should say. So I'll make it blue as well, that way you can see which one I'm talking about. There. Those are the two multiples that, or the two numbers you're finding the multiples of. So multiples that give us 6, 1 times 6 is 6, and 2 times 3 is 6, agreed? So now, we found the multiples that give us the positive 6 on the left side. Let's find the multiples that give us negative 6 on the right side. So negative 1 times 6 will give us negative 6. Negative 2 times 3 will give us negative 6. But be aware of this. Even though those are all the multiples that exist to give you a 6, there are more combinations to give you a negative 6. So we can use 1 times negative 6 and 2 times negative 3. Ooh. So you have 4 possible combinations there to get a negative 6. Combine that with 2 different combinations to get a positive 6. This is going to get tricky because this is the trial and error form of factoring. So through trial and error, let's try to factor. So 2 sets of parentheses with p, some space before the p value there, and then equals 0 because it's equal to 0 according to our original statement. So I'm going to write the positive 6 multiples first because that's what gives us the p squared. So I'm going to just randomly select the first one, which is 1 and 6. There we go, first set of multiples. And once again, I'm going to do the same thing for the other one, just randomly select negative 1 and positive 6, the first multiple. Although I should have probably not done that. But just so you can see that how, or I should say how this one works. So now to try and error, we're going to find out whether this works or not. So in other words, distribute, just like you would normally distribute or expand, right? FOIL, in other words. We're going to go 1 times 1p times 6p times 6 as well. And also negative 1 times 6p and then negative 1 times 6. Once we expand, it should look something like this. So we ended up with 6p squared. As we go 1p times 6p, 1p times 6 will give us negative 6p. Oopsie, may have gotten those backwards. And negative 1 times 6 is negative 6p, and negative 1 times 6 will give us negative 6. Yep, got those backwards, but it still should give you the same. Notice that the 2 middle terms, the negative 6p plus 6p, cancels out, giving us 6p squared minus 6 equals 0. That doesn't work. It does not give us the original negative 5p middle term that we had. So that's a trial and error. Let's try this again. Let's keep the same order for the first 2 numbers, because I got to try both set of numbers again, because there's 2 possible combinations with them. Oh boy. So I'm going to reverse the order of the negative 1 and the 6. So I'm going to say 6 first and then negative 1. Notice it's the same multiples as the previous one. So in this case, distribution. I know already I'm going to get 6p squared and negative 6 at the end, right? It's the 2 middle terms that we're worried about. The 1p times negative 1 will give us negative 1p, and the 6 times 6p will give us 36. So negative 1p plus 36 is the middle term. That will definitely not give us negative 5p, agreed? That'll give us positive 35p. That'll definitely not work. Not worth going any further for that one, because we can already see that. So let's try another set. Which one looks like it'll be a good set of values to use? Well, I kind of did my work a little bit ahead of time. That way I don't spend half an hour to an hour lecturing you here and then getting you bored and not learning anything. So I kind of selected the right ones in this one. So in this case, we're going to go with the positive 2 and positive 3 multiples, and then negative 3 and positive 2 combination there. So negative 3 and positive 2. So I've already even set up my order to make it be correct, to make it a little easier for you. Be aware, this one I would prefer to solve by graphing or quadratic equation. It's a lot easier. Be aware of that. So once again, we already expect the 6p squared and the negative 6. It's part of our expressions. It's part of the multiplied equals 6 and multiplied equals negative 6. We expected to get 6p squared and negative 6. But what we care about is the 2 middle terms. When we multiply 2p times 2 will give us 4. And when we multiply negative 3 times 3 will give us 9, right? So plus 4p minus 9p, the 2 middle terms. Hey, look at that. When we combine them, it gives us negative 5p, which is the original expression. It worked. That is our factored form. So let me just copy down my factored form. 2p minus 3 times in the other set of parentheses, 3p plus 2. And I'm going to have to skip a couple steps. That way you can still visually see clearly here. But otherwise it's similar to before. We're splitting this up. So splitting up into two equations, and you're solving for p in both equations. So for the first one, after you solve for p, you get rid of the 3 by adding, so it becomes a positive 3, and then divide it by 2. So 3 over 2 would be our answer. In the second one, we have positive 2, so it'll be minus 2, and then divided by 3, so it'll be negative 2 over 3. Okay, there we go. But looks like I may have missed that sign. So let me correct it by plugging in our sign, so that should be a negative p, or negative 2/3. There we go. There is our final answer then. Okay, and as a real quick check, that way you can see, let me go for our calculator then. So calculator, that way you can see it on the screen real quick. Go to y equals, well, turn it on first, right? Go to y equals, clear anything you might have from before. And we want to enter 6p squared, but you do not have a p, it's an x for your calculator. So 6x, and I use in this case the exponent of 2 on the left side, right in the middle of your calculator keyboard. So 6x squared minus 5p, or 5x again, minus 6. And you're finding the x-intercepts. So I'll go to zoom, do zoom standard, option 6. And there it is. We can sort of see where they intersect. And if I hit trace, which allows me to enter any x value, I'll put 3 divided by 2. And it should give me a 0. Yeah, it does. And once again, I'll do negative. It has to be the negative sign at the very bottom of your calculator, right next to your enter button. So negative 2 divided by 3 should give you your other 0, or your other intercept. X-intercept, right? There it goes. It does. So there it is. We verified that this works. Our answers are correct. We found the x-intercepts in this case by factoring. Once again, I probably would have done just the direct graphing what we did right now. Be aware of that, okay? Hey, maybe I should get into that real quick for you. How to make your calculator tell you the answers from this one. It's a little more tricky. So let me move the cursor. Wait, too far. If I hit second, trace up at the top right, second to the right I should say, and you want to do the 0 value in this case, rather than intersect, because it's intersect is for two graphs. You want to do the 0, hit enter on the 0 option, and it asks you for a left boundary. So from left to right before it crosses, notice I'm at the left side before it crosses my x-axis. I'll hit enter once. And if you have a T84, it actually draws a line for you. T83s don't, unfortunately. But if I push forward after it crosses my x-axis, there we go, it crossed my x-axis. It's my right boundary now, so I'll hit enter. And it gives you guess, don't want to guess, I'll hit enter. And now it gives me my intersection, negative 0.666, which is pretty much what we got earlier, negative 2/3. We want to find the next one, so we have to do it again. Second, trace, and we want to do 0 once again, the 0 option, option number 2. And I want to be closer to the other side, that way I can actually see it. So left side before it crosses. There we go, that's the left side before it crosses. Hit enter, once again T84s, you might see a line being drawn for you. T83s only, you can see an arrow at the top, so it draws an arrow for you. I'll go to the right after it crosses, there we go, too far, that way you can see the arrow. So there it goes, it crossed, I'll hit enter, and you can see the arrow sort of overlaid into my graph. Kind of makes it blurry. Oh well, you can still see, kind of sort of see it there. So hit enter once again, and now it tells you 0 is a 1.5, which is pretty much what we had there. 3/2 is 1.5. So there is how to have your calculator help you find those intercepts in this case. So once again, secondary check or triple check to find or solve using factoring or using your graphing calculator, or you can graph by hand as well.